Hello everyone. In today's section, we are going to see about image sampling and quantization. Before starting the topic, let me ask you something. Have you ever zoomed an image too much and noticed it looked like a small square boxes? Have you noticed that some images look smooth while others show step-like color bands? And one important question, can a computer store an image exactly like our human eye sees it? The answer is no. Computers cannot store the continuous real-world images directly. They must convert them into a digital form. This conversion process is called image sampling and quantization. Today we will understand this concept in detail. Before designing any imaging system, engineers must understand user requirements. Let us consider medical imaging example. If a radiologist is examining tumor, they need to see very tiny lesions clearly. They need very high detail. If a doctor is checking tissue variation, they need very smooth intensity differences. So here two important questions arise. How much spatial detail is needed? How accurately brightness level should be stored? This understanding helps engineer design proper imaging system. Now engineers face an important design problem. They must decide what sampling rate to use, what quantization level to use. Sampling design number of pixels, quantization decides intensity accuracy. If we choose very high values, image quality becomes excellent, but storage size becomes huge. If we choose very low values, storage reduces, but important details may be lost. So engineers must balance quality and data size. In this stage, the engineers brainstorm possible solutions for sampling, increase the sampling in important regions, reduce sampling in less important areas. For quantization, medical images require high bit depth. Normal multimedia images can use lower bit depth. There is no single correct answer. Engineers choose based on the application requirements. Now let us understand what exactly a digital image is. Mathematically, a digital image is represented as a two-dimensional function f of xy, but practically it is stored as a matrix of numbers. Each element in matrix is called pixel. Each pixel stores brightness or color value at a specific location. So you can imagine images as grid of tiny squares. Each square stores a numerical value. To convert the real-world image into a digital form, two major steps are required. Sampling. It converts the continuous spatial information into a discrete pixel. Quantization converts continuous brightness values into a discrete intensity levels. Both are compulsory. If any one step is missing, digital image cannot exist. Sampling answers one simple question. How many pixels should represent an image? During sampling, images is divided into grid structure. Each grid cell becomes pixel. Important point is more pixel means more detail. Example, high resolution camera produces more pixels compared to low resolution camera. Sampling frequency determines pixel density. High sampling rate, small pixel size, fine detail preserved, and high resolution image. It is a low sampling rate, large pixel size, fine details are lost, poor resolution. Let me give a medical example. Small blood vessels may be visible at high sampling but disappear at low sampling. So sampling directly affects the image clarity. Now let us see what happens if sampling is too low. If sampling frequency is insufficient, high frequency details are mispresented. This error is called aliasing. Visual effect includes jagged edges, distorted object shapes. In medical imaging, aliasing can be dangerous because it may hide or distort disease features. Now we move to second step called quantization. Quantizations, how many brightness levels should each pixel store. In real world, brightness changes continuously, but computers cannot store infinite values. So brightness is rounded into nearest available intensity level. These levels are called quantization levels. Quantization depends on the bit depth. Bit depth means number of bits used to represent pixel intensity. 1 bit means 2 levels, 8 bit means 256 gray levels, and 12 bit means 4096 gray levels. Higher bit depth means more intensity accuracy, better image quality. It is used in a higher storage requirement. So medical image usually uses higher bit depth to detect the subtle tissue differences. If quantization levels are very few, smoothness, brightness transition becomes step-like patterns. This effect is called false countering or banding. Biomedical impact: this small tissues variation may disappear, which may affect the diagnosing accuracy. Now let us compare both concepts. Sampling controls the spatial resolution. It determines the number of pixels, affects the detail clarity. Quantization controls the intensity resolution. It determines the brightness accuracy and affects the smoothness of image. Both are equally important in digital image formation. So overall, to convert real-world images into digital form, sampling controls how finely images is divided. Quantization controls how accurately brightness is stored. Proper selection of these parameters is extremely important, especially in biomedical imaging where small details matter. Thank you.